For your information, groundwater is actually no different than any surface water river, except that this is placed underground. Okay, so in order to find out and get sample for groundwater, it's obviously going to be very different than surface water. So a lot of planning has to be done before we go and sample groundwater. Now here's the thing. Usually, like okay, usually when people want to, when the Department of Environment want to do this sampling, it has to be depending on purpose lah. Because in terms of logistic lah, groundwater sampling is a bit more tedious, a bit more difficult, and obviously very expensive. Simply because you need to dig, you need to prepare some boreholes. So there will be some machines that bore holes deep into the ground until it reaches the water table. And for your information, water table in underground is not just one, they could be more than one, depending on the depth, okay, depending on depth and also the making of the geology of the soil. Sometimes some soil may have more than one river underground. Yeah, so where does all this groundwater comes from? From the underground river, you can say that. Okay, now when I say river, obviously there is flow. So this flow is going to be depending on gravity as well. So when we learn about soil moisture, majority of them is due to gravity. With some of them, maybe a small portion due to hygroscopic interaction with the pores in the soil. So this groundwater will flow with the gravity downwards, and because of the permeability of some soil. Now you know that clay, they don't allow water to seep in. So when this groundwater flow encounters a layer of clay, they're going to flow along with the surface of this clay, and they just flow like, I mean, horizontally. Maybe not exactly horizontally, but they flow like sideways. They never flow up for sure. They flow down because of gravity, and they flow sideways due to preferential flow, probably due to the existence of this clay. Okay, now this kind of flow direction can be determined. And for your information, if you have plans to sample groundwater, first thing that you need to do during sampling plan is you have to determine where is the direction of this groundwater flow. Now, why it is so important? Because you need to know the direction before you can even estimate the mobility or the migration of a said pollutant. Obviously, you do sampling because you want to find out something. So that something, where does it comes from? Where does it goes to after that? So that is why flow is very important. And in order to determine this flow, they were going to use a device called piezometers. Now, I think this piezometers is available in soil lab, but for some reason it's not under soil subject, so it sits there in soil lab. And I never hear that in field trip for water sampling, any students are bringing this device along. For one very simple reason, lah, because you want to do this groundwater sampling, you have to go to a well. Now, these wells are not widely available. Even if they're available, they are usually fenced up, berpagar, because these tube wells are actually monitoring wells owned by Department of Environment. Yes, Department of Environment actually goes around the country, they bore holes, because one of their responsibility is to check the groundwater quality, and they check based on these boreholes. These owns by them. So if you have a chance to work in or have a friend who work in Department of Environment, then only you have access. Otherwise, you don't lah. Yeah, that's why usually when we do our field trip or sampling, we don't touch groundwater lah, because yeah, it's quite hard to do here. By the way, there's another area that constantly monitor groundwater, and that is landfill. You know landfill? Because I mean, that is a place where you deposit all the rubbish, all the solid waste that comes from cities. Obviously, there must be some kind of mechanism to monitor whether there is a leakage from this landfill. And in order to do that, groundwater sampling. Because if there's a spike, if there is a spike of contaminants of any kind, whether organic pollutants or heavy metal, you will see it from groundwater. So most of the time, areas around landfill like Bukit Taga, they have a lot of groundwater monitoring well. So this is what they do as well. Yeah. So once you determine the water flow, then only you have some kind of a device to pull those water up, or perhaps in some cases, some of these well, you don't need to pull it. They automatically spill out. Why? Depends on pressure lah. Yeah. For some reason lah, some of these tube well, you don't even need to pump it. They have enough pressure underground. The water automatically comes out. It's like a geisha where they have built up pressure, high pressure, then it presses out automatically. Those are what we call high flow sampling, which it's usually not the case lah. Because why? We learn about groundwater always flow down, kan? And if they flow down, most of the cases they don't flow against the direction of gravity. So that's why it's very rarely you will see the water automatically comes up. Most of the time you need a device, a pump, so that you can draw water from it. So with that, I think we have seen enough of the instrument. We don't say how to use it and how it functions. So I'm going to leave this lecture slide and move on to my other one. Lecture slide. So this is the one that I prepared myself earlier. So here I'm going to go in details regarding the techniques on how to draw groundwater from tube wells. Okay, a little bit of introduction. Who monitors groundwater? So these three departments are responsible. Now it is said that if it's under the soil, if it's in the soil, it's under the jurisdiction of Jabatan Mineral dan Galian, which is in other words we call it Geology and Minerals Department. So the office is in Ipoh. Now, why we have these two departments? Now, usually, I mean, previously, the existence of mineral and Jabatan Mineral Galian is mainly addressing the mining activities that happened before. So now you know why the headquarters of Jabatan Mineral Galian is in Ipoh. Because if you still remember what happens in Ipoh, yes, tin mining, major tin mining in Ipoh. So that's why they have one over there. It's actually quite well equipped lah. If you haven't do any latihan industry kan, if you have a chance to do latihan industry, why not have a thought of going to that department in Ipoh? Anybody here in Ipoh may want to consider that because this department is very well resourced. They have a lot of money and they buy a lot of high-end equipment. So if you're interested in environmental sampling, they are the place to go. The other one place is Jabatan Alam Sekitar. Obviously, they monitor the pollution level in the environment. So groundwater is part of it. So they also have a say. They look at the pollution. Yeah. Whereas Jabatan Pengaliran and Saliran, this is more towards the cities, which also have a say in in monitoring the groundwater. Okay? Now, before we continue, what makes a groundwater? As you can see right there. Wait a minute. I think I need to stop here for a while. Did I actually explain this part previously? I want a feedback. Did I actually mention? I think I have a memory. Did I explain groundwater that thing?
Yes, explain
Well,
this.
okay.
But in other topic, I think
Okay.
the
So
groundwater zone, right?
did I actually explain this thing about the groundwater monitoring well? Did I?
Yes.
Also,
Kalau well, no, no.
okay, not yet lah. God. Okay, so I think I'll just
The zone,
uh
I think you have.
already
Or
lah. Okay, so
yeah.
I think I'll continue from here. Okay.
Okay.
Okay, so I'm going to come back to the lecture, and this time I'm going to look at. Can you see the lecture slide?
Can.
Yeah,
What?
okay. So like I said to you, each of these groundwater monitoring well, majority of them is owned by Jabatan Alam Sekitar or the Environment Department of Malaysia. Now, some of these groundwater well, they are built to serve a certain purpose. If it's for monitoring the groundwater quality, yes, it's owned by them. But in some cases, some of them might be owned by the cities if it's involved other purpose. So they just have one purpose in order to have a channel for parties interested to know the groundwater quality, then they can come in and sample it. So it's not like as simple as this one. So the build of it is like previously, before you even can see this ground, it is actually soil. Okay, so when they have this one, they're going to bring in machinery, drill it down, removing the underground soil, and then once they have the well, okay, now this well is not finished yet. There's still soil at the walls. Now, if it's not protected due to erosion, uh, I mean the well will going to collapse. They collapse, and then there you go. You need to drill again. So in order to protect the walls from falling down, they'll have to insert some sturdy materials inside. And in this case, I would say most of this material are steel, stainless steel, or whatever steel that can resist corrosion. But as you know, corrosion will happen no matter what. There's no such material that do not corrode. Majority, you can say 99.99% of materials on Earth will corrode due to some cases. Now, this corrosion is not surprising because groundwater is not like surface water. Groundwater is just you can say like groundwater is just slightly less saline than seawater. Seawater is very, very saline, very, very salty. Groundwater, close to that. So that's why whatever materials you dip inside which come in contact with groundwater, because of the salinity, even though without oxygen, they will still going to corrode. Now, corrosion will happen with oxygen, so that's why. Um, Now they insert these metal tubes inside very deep. It's not like this shallow. It could be reaching up to maybe hundreds to 400 meters deep, some even deeper than that. Okay. And then on top of it, in order to prevent any surface soil from coming down, they also construct lah. They reinforce the surrounding of this tube with concrete slab. Because why? People need to step around it. And due to the risk of erosion, it might going to worn out the side and then cause some damage to the top that prevents some entry into this tube. So again, they're going to put some concrete slab, and usually lah, there's a cover. Because why? They don't want anything to come in, so that because whatever that goes in may have a risk of contamination. So that's why it is covered all the time. And one more thing is that groundwater should remain groundwater as it is and remains covered. Now, due to the fact that they remove some soil in here, this is a passage that may be the source of contamination into the groundwater. Now, what not? If you keep this lid open, what will comes in? Rainwater, betul tak? Okay, rainwater may goes in, and if that happens, it may have a dilution factor to the existing nature of the groundwater, which even though it dilutes down the thing, it is also some, what we say, artifacts or contamination. It is not, okay, contamination may not be the best word to this one. This is more towards the disruption to the original nature of the groundwater. So that's why it needs to be covered. And one more thing, why it needs to be covered, prevent oxygen to comes in as well. So after concrete slab, you have like pagar, the fence up area, so that no vandals can go in and do anything. Yeah. Okay. Now, this installation will need to be conducted in order before you can even consider sampling groundwater. Um, okay, now I think I need to add something because there are some things that is not being explained here. Okay, I think I'll just skip here first, okay? Because I think it's better for me to tell you the preparation first. Now, you have constructed a tube well. Next thing, of course, you need to sample, kan? But before you put in this instrument, you need to do something, okay? And that is a preparation, which is right here, okay? Now, you need to, okay, Before you do this routine groundwater sampling, you need to characterize the flow. That's what I told you earlier by using piezometer. So after you use piezometer, you have a tube well. The second step you need to do is not directly sample. You will need to purge and stabilize groundwater. Now, this is akin of QC procedure. If you still remember in sampling plan, almost all sampling work, no matter what media that you want to sample, whether air, soil, or water, you will need to have QC. QC is something that you do. QC procedure is something that you do in order to minimize the source of error. And number two is one. Number two is one, but for sampling groundwater. Now, what are you doing in this purging and stabilizing is simply removing the the trap the trap region. Okay, water, groundwater that is trapped inside the tube. Okay, why do we need to remove that? For very simple reason. Groundwater is saline. It comes in contact with the inside of the steel tube. I think that's very obvious, kan? Corrosion may happen. So when corrosion happens, does that trap groundwater reflect the nature of the groundwater? Certainly it will not. Because why? During corrosion, let's say the steel tube is made majority by iron steel. When it corrodes, it will release iron into the groundwater. So the trap region may have a higher level of iron, which is not the original nature of the groundwater. So in order to prevent misinterpretation, you get the wrong sample. So very easy. You open the cover, okay, before you collect the real groundwater sample, open the cover, purging. Purging means you remove the region where it is trapped. And sometimes we don't just remove that volume only. Sometimes we remove 2-3 volumes of the trap region. Say for example, if that region that you know is trapped with maybe 1 liter, perhaps you might want to remove 3 liters at least, so that whatever the fresh water that were fresh groundwater that comes in, it reflects, it actually represent the groundwater in the area and not the one that traps in the tube well. Okay? So next one is stabilize the groundwater. Now this stabilization is some additional work, and this would be steaming. Wait, let me see if there's any. Yeah. So I think I will go through this page first. Yeah, like I said to you, the stagnant water that trapped inside the tube, you need to remove it. And then the stabilization is once you have removed the trap or the stagnant water, groundwater in the tube, stabilization is you steam it, remove it some more, and then you check again the parameter. Now, before you grab the actual groundwater to bring back into the lab, it is very important that you check the parameters of those groundwater. See if they are stable. So if you have removed and purged the stagnant water, put in some probes, and then you measure you measure the first reading. Then after that, repeat again with the second volume. If they are the same, it is said to be the groundwater is stabilized. Because why? Now let's say if you forgot to purge the stagnant water, what happened is the parameters of the stagnant water will be very different than the purged water, the one that comes in later after that. So due to this difference, you cannot start collecting the groundwater. You have to continue purging until you can find like no difference in parameter after successive volume of the purge water. Okay, so once you have determined that, okay, there's not much of difference in terms of groundwater parameters, then only you get your sample bottle, then you fill in as usual, depending on what groundwater contaminants that you're looking. If it's volatile, if you still remember volatile, what you should do, take your sample bottle, fill it to the top, close it, maybe put some preservative, whatever that I've told you 2 weeks ago. It's quite similar to the surface water sampling in terms of preservation and also storage. Okay. So, okay, if you look at these parameters, like, what are the things that we usually see? Number one, if not mistaken, is pH. pH is always number one. And number two is electrical conductivity. Now, this one, the main reason why we determine this is so easy to determine. You can have like a pH meter coupled with electrical conductivity, dip it in straight away, you know it. So these are the parameters that's measured right away, like, just like when we sample surface water, because we can. No need to bring back to lab, like that. You can do it right away. And in some cases, some of the probe already equipped with oxidation and reduction potential. Now, why this is determined? Now, I believe you may not see this one in surface water because it's not an issue. Surface water constantly exposed to the air. They are constantly oxidized. However, groundwater is a different story. They are subsurface. They don't come in contact with water. In this case, the ORP value, the ORP value may vary depending on how much of oxygen they will come in contact. So this is also one parameters only measured for groundwater. Apart from that is specific conductivity. Turbidity is another dissolved oxygen. Dissolved oxygen actually is very closely related to this one. However, I think the one probe that you possibly can use to identify dissolved oxygen is the YSI array. Yeah, the one that you use for surface water monitoring are that one. So what you can say, you can quite safely say that for groundwater sampling, the equipment more or less the same, more or less the same with surface water, plus like you need something extra. So what is extra is the pump. So yeah, so why would we even need to do all those purging and also stabilization? That is because we want to ensure that there's no contamination. So here you go. Where does the contamination comes from? From your equipment, from the walls of the tube. So I consider as part of the equipment lah, yeah. And some more, when you want to collect groundwater sample, you were going to use very long tubes. And here's the thing, these tubes, they are not cheap, you know. It's not that you use a tube once and then you can discard it. No, it doesn't work that way. Tubes, in this case, they have to be quite sturdy, and usually we don't discard it after one use. You will need to bring back to the lab, clean it for second use. So let's say for example, there are some very tough stain, very tough contaminants from the previous sampling trip. It is not removed. That might be a source also of your contamination lah. Yep. So I think I will go back again. So once we have determined that the tube well is already stabilized and it's quite safe to say no contamination, then only we collect it. Okay, how do we collect? In this case, we are going to explore items that is reserved for low flow or no flow tube wells. Low flow or medium flow or no flow tube wells are actually those wells that do not spews up groundwater. So you need to go down there and collect it. Of course, it's not you. You put something into the ground so that it fills that item, and then you collect it later after you pull it up. It's just like what you do in kampung when you have a perigi, you put a baldi in there and then you tarik, 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 tarik. This is how it works. But we don't call this baldi we call it a baler. Yeah. It's actually a very long plastic tube. At the bottom here, at the bottom of this plastic tube, it is transparent, by the way. It is transparent plastic, and then at the bottom here, they have like a plampo, a floating device that I'm not sure how it works, but somehow when you put it down, I mean, groundwater will going to flow in at the bottom. Groundwater will going to flow in at the bottom, and then you're going to fill up the entire chamber. Then after that, when you pull it up, it will going to automatically lock this inlet and then secure the content of this groundwater. And then after that, what do? You pull the cable up, then only you pour it out again using the same way it comes in. And then after that, you repeat the entire process again. I myself have already used this baler before, and it's quite tedious lah, because you have to insert it carefully with the ropes, and then after you fill it, then you pull it up, and each time you pull up, the volume is not that much, very little, or at least not enough lah, because usually lah, when we talk about water sampling, we're not collecting 100 mils, we're collecting probably 20 to 50 liters, 20 to 50 liters, just in case lah. We want to collect more so that after this, in case anything happen, we still have some stock. No need to go back and repeat the sampling. Okay, so this is method number one. And well, this baler can be used to sample any groundwater lah. No need to worry about what kind of pollutants, VOC, heavy metals it will do. Okay, now people have gotten smarter. They know using baler is going to be too laborious, too tedious, and they have invented one device called a pump. Now this pump is not pumping air; it's drawing water. How does it do? It uses a peristatic pump. Now how this peristatic pump a draw water from groundwater? As you can see right there, you're actually looking at this device from the top. So from the top, you can see this peristaltic pump. It's uh, it's coiled with the tube. Now this tube, one that goes into your sample bottle on the surface. So imagine that you're sitting on the soil surface. So this one is what you're holding in order to insert into your sample bottle. The other one end will be placed into the tube well. So this one you have to be very long lah. Okay. And then what happened here is this is actually the pump with a rotor. A rotor means something that you can spin in one direction constantly, and the speed can be controlled. So based on this speed, it will going to draw water at the different speed at your liking lah, how fast you want to draw this water. So it's quite easy to do lah. What you need is electricity, put this tube in, and then just sit on top, wait. So very easy to do. But this one actually what they say is they have limitation. Now, if you learn physics, kan, if you want to draw moisture, the deeper the tube well, the harder it will go to draw. Because what? Imagine like this silicone tube. If you have a silicone tube and you're sucking this tube, imagine that if you have like a very tough, I mean, how do I say it? At a certain point now, if this tube is too long, it can be imagined that you will going to like having a very tough time trying to remove this liquid for a long distance inside this tube. So what happened here is if the force of the suction is too strong, if the force of suction is too strong, the atmosphere will going to press this tube. So what happened is your silicone tube, instead of staying like that, it will going to collapse because of the vacuum inside. What happened is halfway when you're drawing this groundwater, you might discover, hey, sometimes it stopped. Okay, at times it will stop. Why? Because there might be some cases, some part of this tube might collapse. They just close, collapse, and then no water can flow through. So that is the problem of peristaltic pump. It will only work if the length of the tube is not too long. If it's too long, then it will collapse lah. Cannot do. That's why they say lah, 25 feet only is a limitation. Longer than that, it depends. It depends on what kind of material is in your tube. If your tube is like a very sturdy plastic tube, then it will work. But if it's silicone, then it cannot lah. Yeah. That is why this device is most preferred. We call it a bladder pump. Now, bladder pump is still called a pump, but in essence, the way they work is quite different. Now, in this case, guys, if you look at the video, you can look at the video later, but what I can explain to you is that it works by giving pressure. Okay, it works by giving pressure deep into underground soil. So in this level, they're going to press and then sense groundwater upwards. So they're going to create pressure. They're going to create pressure deep underground so that those groundwater will be pressed upwards and go up. And in this way, it will work much more deeper. So if peristaltic pump by using suction can only work in less than 25 feet, this one will work at approximately 100 feet. So bladder pump is much more better in this way. And plus, using bladder pump, you won't going to uh, have any glitches lah. Glitches mean during the pumping process, instead of having a smooth and constant flow, peristaltic pump might going to stop halfway due to the collapsing of the tube, but this one will not lah. Okay, so why that is so important, apart from wasting your time trying to fix a problem, I mean, the one issue of having these glitches is that you will need to actually measure the flow. In groundwater sampling, it is also needed to measure the flow during the pumping process because you will be able to calculate the volume. From the constant flow that you have, you can calculate the volume. Okay? The volume of the groundwater that you're sampling. Yeah? So that is the instrument that you need to know. So just three, and then the rest of it, once you have your sample, just bring back in, fill in the chain of custody form, and yeah, that should be it.